Our next session, AI-ready grids, integrating hyperscale loads faster, cleaner, and cheaper. Please welcome to the stage Jackson Ewing, Director of Energy and Climate Policy, Nicholas Institute for Energy, Environment, and Sustainability, Duke University.
Good afternoon, everyone, and thank you for spending the last session of the day with us. My name is Jackson Ewing. I'm the Director of Energy and Climate Policy at the Duke University Nicholas Institute. It's my privilege to chair this panel today on AI-ready grids, integrating hyperscale loads faster, cleaner, and cheaper. We're in the midst of a digital technology infrastructure revolution, and it's going to touch virtually all components of our society and our economy. It's going to lead to innovations that we can't even imagine at present and have the sorts of impacts that can be transformative for our energy systems and beyond. It also, paradoxically, requires an enormous amount of energy. And it does so at a time when many of our energy systems around the country are already in need of modernization, not least of all because of the requirements to onboard more renewable and low carbon energy to face the climate crisis. These are the sorts of things we're going to talk about in our panel today, and I'm really, really fortunate to have the lineup that we have. I'll begin by just introducing them briefly, and then we'll dive right in. To my immediate left, we have Caroline Golan, who recently became the CEO and founder of Envision Energy Advisors after spending 7.5 years as the global head of energy market development and innovation at Google. David Dardis is the Executive Vice President and Chief Legal and Policy Officer at Constellation Energy. Tyler Norris is the JB Duke Fellow for Energy Systems at the Duke University Nicholas School of Environment. And Jeff Bladen is the Head of Energy at Veris and former Global Director of Energy at Meta. So, Caroline, let's start with you. You spoke recently about how data centers and energy infrastructure are too often treated separately, rather than being planned together, and that the procurement and design models need to shift from the just-in-time to the long-term scale-based planning. So how do we make this happen? And how can we lead to large load integration that's faster as a result?
Yeah. Well, thank you everyone for being here, and thank you for the time. What I've seen over the past decade really within the data center market is, a recognition that we are going from a get a cloud customer, build a data center, get a cloud customer, build a data center approach, which is really where the market was for many years, to recognizing that we are going to be building gigawatts of scale for many, many, many years to come. And so when you move into that space, you have to start thinking about countries at a single time, as opposed to one municipality within one state or one area of the country. You have to think at the country level of how you're going to plan gigawatts of deployed capacity. This is hitting at a time where I think the utilities across the country have been used to the model of get an industrial customer, sign an ESA. Get an industrial customer, sign an ESA. There was no large load queue. There was no real process to integrate gigawatts at scale, right? It was 1 or 2 applications a year. So both business models reflected each other and sort of are coming at this at an equal inopportune moment, right? So what I see is critical, I think, moving forward is a bigger and better planning approach. It's really just that simple. So when you think about procurement at scale, you're thinking across PJM, you're thinking at holding company level across utilities. If hyperscalers can be transparent about that and open up the books and work with their utilities, the utilities can then really see 1, 2, 3, 4, 5 years out how many gigawatts they're dealing with, as opposed to this put in an application service, put in an application service. So it's part of this opening up the process together. I think the other thing that I really see that's critical is understanding that I know we'll talk about this today, but what the hyperscalers' role is, what data centers' role is in leading to that capacity addition. And that looks like opportunities of new flexibility. I think that looks like opportunities of joint procurement, joint investment, but it really has to start with a fundamental new approach to planning, which puts load and capacity growth from the industrial sector at the forefront and opens up the entire book and sort of how you meet that, which is radically different than how we've ever done it before. It was sort of one person in the door at a time, and now you got to fit thousands of people at once, and you have to change the way you look at planning.
Yeah, thanks. That's a great context setter. And David, I think you're living this reality on a day-to-day basis. Your organization delivers power to meet these large load growths, and your role has you navigating a lot of the complex regulatory environments, some of which we just heard about, in order to do so. So what levers of policy, subnational or national levels are needed to meet growing demand, and how do you do that while also pursuing some of your environmental reliability and ratepayer goals?
Yeah, it's a huge challenge. And if you break this down, maybe just take a case example. We're living this every day in PJM, which is where most of our assets reside. And this is where the issue is really joined in a pretty intense level. And I also think about this for the next 5 to 7 years, and we're really trying to deal with this near-term challenge of load growth, prices, and still protecting the market is kind of the intersection we're trying to achieve, and also be wary of the sustainability goals long term. And I really think of 3 things that are coming to mind that we're working on. The first, and this might not be a surprise, coming from the largest nuclear owner-operator in the United States, we have to protect and preserve the existing nuclear fleet, which provides over 20% of the power to PJM today. And just a handful of years ago, we were shutting down nuclear reactors prematurely, and we have to protect those. So there's a good news, bad news story about this. First, most recently, Congress, in the Big Beautiful Bill, reaffirmed its commitment to the nuclear production tax credit, and that's essential for the existing nuclear fleet to continue to operate for the next decade and beyond. That's fully supported by Democrats under the IRA and 100% supported by Republicans in BBB. So really a tremendous accomplishment. The bad news side of that story is there's a lot of discussion at the state level of policies which go the opposite way and frankly threaten the existing resources. Concepts like vintage pricing, rate-based generation, re-regulation, all those things put downward pressure. They're massive political interventions in competitive markets, and what that does is threaten existing resources like nuclear. We can't spend the tens of billions of dollars necessary to relicense our nuclear plants if anytime there's a little blip in supply-demand fundamentals, that the state policymakers decide they've got to change the rules of the game. So that's a big one. Second, we have a huge issue around load forecasting. I'm not going to go through all the math, but just really quickly, the total hyperscaler budget globally, capital budget, is about $350 billion a year. Use my Google AI this morning to look that up. A 1 gigawatt data center costs about $35 billion to build. If you count the chips plus the balance of plant, that's rough numbers. That's close enough for lawyer math. That gets you 10 gigs globally a year. Some of these numbers, PJM's projecting 60 gigs in 5 years just in PJM. Texas is predicting 70 gigs in Texas in 5 years. Those numbers just don't match. We have to solve the load forecasting issue. And then, finally, we have to keep everything that we can online. That runs a little bit counter to the sustainability message, but for at least for the next 5 years, we've got to preserve all the existing assets. We've talked to some governors about ways in which we can keep online some of the gas plants that are scheduled to retire in the next handful of years and still lower emissions. And we need solutions like that to ensure we meet the reliability requirements and allow this economy to grow the way it should.
Yeah. Thanks, and I know we've seen a shot across the bow of PJM just this week. It speaks to some of the regional state interactions that you and Carolina both brought up, so thank you for that. Tyler, I want you to move us to a discussion of flexibility. We've been talking so far about how to build the necessary generation and transmission and the different regulatory environments that are necessary to do so to meet this growing demand and the realisticness of our current trajectory on that. But you take a slightly different take in some of your work, particularly your Rethinking Load Growth paper, which argues that even fairly modest curtailments of new data center loads could unlock tens of gigawatts of new grid capacity without added generation, taking advantage of some of the headroom that exists in the system. So can you please explain to us what you found and what you think the implications of it are?
Yeah, thanks, Jackson. Great to be with you all. So the context and part of what motivated the paper was looking at these peak load forecasts for the US. We're at about approximately 700 gigawatt national peak right now. And the forecast is we might get as high as 850 gigawatts by the mid-2030s. That might be on the high end, add a little reserve margin to that. And even if you wanted to do as much of that with gas turbines as you could, we know the forecasts are somewhere between, say, 60 to 80 gigawatts of gas turbine supply that could be available in that timescale. So we might have a gap, right, of when you add reserve margin of up to 100 gigawatts. And so certainly battery storage can play a role, solar and wind, where they could have capacity value, can contribute, offshore wind. But I think to meet that kind of forecast, you're going to have to bring demand more into the equation. And so when we dug into the numbers, the question we were just asking was, how much would the new load have to flex on average in a given year such that you could add it to the existing power systems without exceeding the existing realized peaks that those systems have already planned for? And what we found shocked us. And actually, initially we ran it with much higher rates of annual curtailment, closer to 1% to 2%. But the amount of headroom that was showing up nationally convinced us, let's go all the way down to 0.25%. So meaning if a new load was able and willing to curtail itself, its draw from the grid, for 0.25% of its maximum annual uptime, either via on-site storage, generation, actually flexing the computational workloads or otherwise reducing operations, and the numbers added up to 76 gigawatts nationally and approximately 15 just in PJM. And so that's, I think, an exciting opportunity. And I think what it illustrates, right, and what we know, but it's always good to remind ourselves that we build the entire power system to serve extreme peaks in demand that occur during the most extreme weather systems. And so, the good news story is that outside of those most extreme peaks, which vary from system to system, but generally average, say, 100 to 200 hours a year, outside of those most extreme periods, there is headroom on the system. And so we could actually add a lot of load if it's able to be a little bit flexible, or if, and I know Caroline will speak to this, if other loads are able to be a bit more flexible. And so there might be actually some interesting flexibility markets and opportunity there. But I think all this kind of goes a little counter to the way we've thought about this recently, which is that the whole system is maxed out. All we can do to get more load or generation on the system is to build more transmission and distribution. And by the way, we absolutely should be doing proactive transmission planning. It's going to be critical. But I think when we kind of look at it in a slightly different way, we can realize there's opportunity to add a lot of load more quickly and more cost effectively than perhaps we originally thought.
And I think that where you landed there is an important part of that argument, and you are quite clear about this in the piece, in the sense that this is a stopgap measure, at least to a certain extent, as more generation comes on board. That doesn't mean flexibility disappears, but it means that it's something that can be arguably done immediately to meet some of the really urgent demands that we're seeing. Jeff, this dovetails quite closely in some ways with your business model at Verus, and Tyler referenced some of what the flexibility infrastructure would need to be. That's what you are building. So can you tell us a bit about some of Verus's innovative physical design solutions, batteries, microgrid-like electrical networks that can enable the kinds of flexibilities? And beyond that, what sort of technical and regulatory or contract innovations are really needed to see that scale up further?
Yeah, thank you, and thanks for the chance to be here. I appreciate that. I'll make a quick side note, which is before I was at Meta, I spent about half of my career leading parts of markets and operations at two big grids, PJM and MISO, and I have to say very clearly that we have to build more transmission. So I just want to get that out of the way. We have to build a lot more transmission. I have a t-shirt at home that says no transition without transmission. I believe that. So the world that Tyler described in theoretical terms, Verus was founded to be the physical manifestation of what it looks like to actually extract this extraordinary amount of energy that is essentially being left untapped by the assets that already exist, the backbone transmission and the generating fleet in the US and really in other parts of the developed world are left untapped a third of the time. I mean, some very, very large number of megawatt hours are left untapped. And we were founded back in 2023 with this in mind. How can we do two things? One, make the grid way more efficient, which harkens back to my life in the big grid world of if we can get the demand side to flex, we can be way more reliable, way more affordable, and much more sustainable over time. How can we do that in a way that recognizes one of the great challenges for data centers, which is a desire not to have the workloads inside the data centers be compromised. And the reason for that is that these are massive capital assets, as David was alluding to, and the notion that you would build a massive capital asset and then underutilize it sort of runs counter to the whole premise. And so Verus was founded with two big fundamental innovations. One focused on inside the campus, how to make the campus data center far more efficient, where traditional data centers might be somewhere in the 65% load factor, meaning they're using about 65% of the megawatt hours that are reserved for them, which is actually not that far off from what the big grid does. Our data centers will use something like 90% of the megawatt hours reserved for us. So far more efficient inside the data center, getting more megawatt hours of compute out of the same megawatts of interconnect. And then the corollary to that is that internal innovation unlocks our ability to be flexible in the way Tyler was describing, which is for hundreds of hours of the year, which is actually exceeds the 0.25% that Tyler was describing. We can be flexible for the utility to shave off those peak periods and really just consume during the rest of the year when there's plenty of excess energy. And those two fundamental innovations will allow us to do what we really have to do right now, which is to get more out of the grid we have while we're building the grid we need. It's the only way we're going to even come close to meeting this transformational time in our economy. And I am a big believer that there is huge value creation in front of us for all of society in this emerging new technological capability. But we're going to be constrained in actually unlocking that, but for these innovations. Yeah. And we're excited to be headed towards developing these new kinds of data centers, and looking forward to finishing this conversation.
Yeah, and can I just add really one additional? Yeah. I have the same T-shirt somewhere at home, and I think the other T-shirt that we all need is like we need to keep investing in clean, firm options. Yeah. And to your point, this can be seen as a bridge there. And one of the worries from my side, at least, is that if we don't tap into the demand side, we may actually overbuild on gas in a way that actually could crowd out some of the clean firm options that we want to scale in the 2030s. Yeah. And that actually is sort of what happened in the early 2000s when we went a little too long on gas.
Mm-hmm. Thanks. Carolyn, you have a slightly different take on this flexibility thesis, and I want to give space for that. And particularly, Tyler teed up, you might see flexibility outside of the data center users. So I'd love to hear you explain that. But also, just as importantly, what do we need to know about the computing needs of data centers and what the barriers to curtailment are in many instances?
Yeah. So if you look at the data center market, you sort of have three major segments, right? Hyperscalers make up about 60%. 60-70% of the market of load growth, at least it's coming into this country. You've got colo providers, and you've got enterprise providers. I want to take the hyperscalers for a second. These are your big tech companies that are always in the news and always blamed for everything. So that was a joke. Okay. So these are the companies that are building 1, 2, 3, 4. Sam Altman is announcing, 10 gigawatt data centers. So you're talking about infrastructure that has been technically spec'd for multiple years before it hits deployment because of the size. You're also talking about infrastructure that is running hundreds and thousands of dollars of chips per minute. So every minute is hundreds and thousands of dollars of analytical research that these big campuses are doing to produce the intelligence that is going to then go into the economy, right? So when you think about the value add of flexibility for someone who's saying, I'm going to stop hundreds and thousands of dollars of research for a couple of minutes to an hour, there isn't a market signal in the country based on what we currently value and energy prices that is going to meet that cost signal. So essentially, the opportunity cost of being hyper flexible for these large data centers that are AI training data centers is not there right now. There is a benefit if it means that because they are flexible, they can get online quicker, right? So that they can actually get to the capacity that they want, because as Tyler said, headroom planning in this country is very risk averse, right? And so I think that if it means you can get online faster, then that's great. There's a value add there. To the degree that we have a marginal speed or marginal cost for speed to power priced yet, we don't have that. But if you take a step back and you say, you have a segment of the load growth, 60% at least, that really just cares about getting online fast. What do you do with that capital? What's the highest and best use of streamlining that capital? We know flexibility needs to be part of the system in any situation, but what type of flexibility do we want to invest in for the next 10, 15, 20 years growth of the grid? Because after data centers, it's electric vehicles. Globally, it's air conditioning, which is actually the largest grower of load globally, is air conditioning. And then you have the electrification of traditional industrials. So you need to invest in the interoperability and the flexibility of the grid at whole, instead of saying, the hyperscalers, you have to be flexible and you have to do this. I would invite the opportunity to say, where could we put that willingness to pay across the grid to extract those megawatt hours and create a better setup long term? I will also say that when you ask about computing, and I've talked too much already, but I'll add this, a great hybrid, I think, between both of this is the strategic placement of storage. A lot of AI training right now is incredibly erratic. And that is going to look like storage inside the servers to smooth out training load. And it could like grid-tied storage to also smooth out the training load at a larger level. So how do hyperscalers and utilities work together to maximize the value of a storage asset beyond what it usually gets priced in the market for now, which is generation, which is, probably the last thing we should be using storage for right now. And so I think that if we can look at storage at this multi-use asset, bring together contract structures that let big AI data centers use storage to smooth out their own training, be flexible, and then also use that asset as an ancillary service asset or overall peak reduction asset, then like that's the key to me. But there aren't a ton of contract structures out there to do that, utilities that have processes to do that, and the market doesn't value that multi-use right now.
Jeff, I see you nodding vigorously down there, and I know you have some positions on workload scheduling evolutions, on what sort of incentives and market structures are needed to get that kind of flexibility contract off the ground. What's your take?
I think Carolyn said it incredibly well, which is, as we're doing at Verus, we're using batteries like the Swiss Army knife that they truly are in the electric system to deliver massive improvements in the efficiency of the data center itself, but also then provide the grid the kind of flexibility it needs. Not every data center is going to be set up to do that, nor should we expect it to, as Carolyn said. And but what we need is to reform our process for thinking about how we connect loads to the grid, to look at them not just as a load, as a customer, but also potentially as an asset. And that once we shift our mindset, shift our planning processes, shift our study processes such that we can think of these as grid assets, those that want to be grid assets, then we will have the opportunity to leverage them in many of the ways that Carolyn was just describing. That's a challenge in front of us because our entire framework for interconnecting supply and demand is built on a cautious framework, one that we're trying to avoid causing disruptions, causing outages, potentially blowing things up. And what we need to do is we need to rethink how we approach the study of customers such that they can be assets, that they can be part of the planning process, whether it's distributed in the form of sending a better price signal for air conditioner controls, or if it's localized like a data center like ours that is going to have massive amounts of battery storage to make sure that we get the benefit of being a grid asset and not just the cost of a slow interconnection process.
Yeah, if I could jump in on this. At Constellation, we serve about 75% of the Fortune 100 companies in the United States. We have a massive load book that we serve. And our CEO gave us a challenge a couple months ago to go find 2 gigawatts of flexible load in our portfolio that we could use to pair with these less flexible customers that we're also trying to serve. And using Caroline's numbers, there's no value of lost load that's going to approach the numbers that these hyperscalers are putting on the value of their compute. And however, you can find other customers at a much lower price who are willing to curtail for something much less than the hyperscaler would need to curtail. And in December, we're going to have already 1 gigawatt of flexible load under contract that we're going to use AI to manage their load. And we get another gigawatt. That's a huge benefit to the system, and there's more available. So that's really the type of solution that we're working with our customers on. It's a virtual data center flexibility product.
Yeah. I want to stick with you on that, David. I mean, what went into the coordination for matching up those 2 loads and creating that kind of flexibility you just described? And also, maybe a slightly related note, how do you manage those sorts of arrangements and others in terms of service tiers and the different kinds of firm and non-firm power that are at play here?
Yeah, I mean, it's when you've got a large enough portfolio, you have a lot more options to match the time use of the customer, and you can really clip the peaks on the system. Using the Duke study, I mean, the 0.25 number is pretty interesting. The number that's always in my head is half of 1% in PJM. You could add 18 gigawatts of new load to the system if you believe this study, which we do. And so there's, just an incredible amount of value that can be provided to the overall system by working with these customers. And it is going to require a big technological solution to solve that match between the data center load and the other non-data center load, but it's available to us today.
Yeah, thanks. We're running short on time. We are the last panel, so I'm going to take the luxury of maybe spilling over just a minute or two, but we'll be respectful of your time. I'd like to hear from everyone just some wrap-up comments about maybe what we didn't touch on that's front of mind for you, and particularly what are the most important priorities that you see in your respective sectors over the remainder of the decade in particular, and then 2030 and beyond. Jeff, let's start with you and just move towards me.
I think we have to be mindful of the potential opportunity in front of us to have a transformational technology that won't just change our economy, but in all likelihood, based on some studies I've seen, will make our ability to transition to a cleaner economy much, much faster and more efficient. And so unlocking the capacity to drive this innovation forward isn't, as some would describe it, a cost to our environment, potentially a huge benefit to our environment. So I don't want to lose sight of that as we think about what does it take to actually power these kinds of data centers. Having said that, it doesn't mean we should do it inefficiently. It doesn't mean we should do it unsustainably where we are able to make good choices. And that's the other side of this coin, which is, as I said earlier, we need to do everything we can to get more out of the grid we have while we're building the grid we need or want. And that looks like extracting all of this unused capacity as much as we can, while we're also building all that transmission that's going to allow us to bring new sources of energy to the market. And ultimately, we also need to fundamentally reshape how we think about the grid connection process, both on the supply and the demand side. If we don't, I think we'll end up in a policy place that none of us really think is going to be a good place to end up.
Tyler?
Yeah, I'll try to make this really brief. And actually, a lot of our lab's research also looks at generator interconnection, and there's actually a lot of similarity for both generator interconnection and large load interconnection. We sort of created this administrative construct where you're sort of either fully firm or you're 100% non-firm. And this is an artificial construct, right? It's actually really, there's a spectrum of firmness in there. And I raise it because this is what Jeff was getting at, is that we sort of push everything to be fully firm, and that's a very restrictive set of standards and study criteria. And that's oftentimes what drives all the need for this new infrastructure. And so I think one of the tasks in front of us is to figure out what do quasi-firm service tiers look like, possibly. By the way, we don't even have non-firm service at the transmission level for large loads, so we should at minimum have that on a voluntary basis. But I think there's an interesting opportunity to look at a broader spectrum of options, both for loads and generators.
Thanks. David?
Yeah, so I'm going to borrow a phrase I heard today from Arshad at EPRI. We're no longer calling these data centers, they're knowledge factories. It's input of electricity, and out is a knowledge token. And there's this notion that data centers are taking electricity and just sort of pumping it into the ground. But that's absolutely not what's happening. I believe, and we believe, that the knowledge and the challenges that will be solved by this technology will change the course of humanity. And whether or not we in America's place in the world will be affected by how we do in growing this part of the economy. And we have to remember that that's what's in front of us. And what's the punchline here? The punchline for me, and maybe this is a little bit self-interested because I'm spending my time in all these glamorous places like Harrisburg and Springfield. Annapolis is a little bit better, these state capitals, but we've got to look past our parochial interests on a policymaker level, because this is as important as winning World War II. It's as important as the race to the moon for our country, and the policymakers need to come together and look at the bigger picture, what we're trying to achieve, and not get into the weeds on these fights over utility interest and rate base and all these things that we're fighting at in these state capitals, and look at the bigger picture.
Yeah. Since we're at Climate Week, I think I would be remiss if I didn't call out that so much of the capital that has been flooded into the clean energy transition in this country came from customers who had voluntary climate goals. And so their entire agenda and responsibility to the grid has been to meet their climate goals. And I think now we're in this era where the world is saying it's our responsibility to build, finance, figure out the regulations, and streamline new capacity, which is a very different agenda. And the idea of transitioning, I say this, transitioning from what has been an offsetter to a prosumer is a wildly tough challenge. And I think we keep asking the question, but will they meet their climate goal? Instead of asking the question, what is the highest and best use of these, what did you say, $350 billion that are going to go into the grid?
Annually.
Annually.
Yeah.
And I think if the climate community could start asking that question, we come up with a lot better help in finding the solution.
Thanks so much, Carolyn. You anticipated my closing thoughts, but did so much more articulately than I was going to. Please join me in thanking our panel for such a solutions-oriented final discussion of the day.